Hello and welcome to my channel. I am the Mad Computer Scientist. On this channel we talk about computer science, technology, and math topics that interest me. But before we get into today's video, I would like to ask you, if you are new here, to hit that like button. If you haven't subscribed, please do so already. If you find this content useful, share it with your friends, and please hit the subscribe button and remember to ring that notification bell. If there's one thing that comes up during AI discussions frequently, it is the topic of the Turing Test. Now, the Turing Test is somewhat controversial, especially if you're discussing whether or not the Turing Test is still useful. But a lot of people probably need a refresher as to what the Turing Test is. We will get into the controversy a little bit later. The Turing Test basically is a way to test for artificial intelligence. You basically have three people. You have a man, a woman, and an interrogator. Now, the interrogator does not know who the man and the woman are. This is done through a teletype machine in Turing's original formulation, which is described in the paper Computing and Machine Intelligence, which I will link below. And at some point, the woman is switched out for a computer. Now, the role of the interrogator, the person who's actually playing the game, is to try and guess which one of the other people he thinks he's talking to is the woman. Now, Turing throws a little twist on this test. At some point, the woman is switched out for a computer. If the interrogator in the game correctly, or rather incorrectly, guesses that the interrogator who is the woman, the machine has passed the Turing test. Now, I'm going to ask you to do a little experiment here and go to a computer science website and see if you can find what they have to say about the Turing test. I'll give you a few seconds, and I'm not going to ask you to pause the video. I'll just continue speaking while you look it up. Okay, have you had time to look it up? I bet if you actually did go to an actual computer science university website, at most you found a paragraph or two. Now I want you to do something else. I want you to go to the Stanford Encyclopedia of Philosophy and look at its entry on the Turing test. You can see they have quite a bit more to say about the Turing test than you might expect, especially since the Stanford Encyclopedia of Philosophy is not a computer science resource. And the fact that they do have quite a bit to say about it suggests that the Turing test actually has important implications for the nature of consciousness and how we define it. Because I am not a philosopher, I am not going to comment on anything the Stanford Encyclopedia of Philosophy has to say about it. Over the years, the relevance of the Turing test has come into question. Even though today there is still contests where people try to get their chatbots, usually, to pass the Turing test, one thing that caused people to realize it might not be as useful as once thought was the introduction of a chatbot called Eliza. Now, Eliza was actually fairly good at passing the Turing test as long as you asked it therapist-like questions. If you went outside the field of psychology, it didn't do as good of a job. And the reason I'm bringing that up is because this showed us something about how we currently do artificial intelligence and how it's being done today. Most of the things that are billed as AI programs are either generative AI or a specific form of generative AI known as the large language model. What most AI programs are designed to do in the modern era is to do one task and do that task well. If you ask it to do something else, it's not going to do that task well. For example, ChatGPT is really good at coming up with human-sounding responses. It's not so good at generating art. It is also, and I hope I'm not offending any OpenAI programmers by saying this, terrible at generating code. Although, when it was introduced, Google's Gemini was actually slightly worse. My thoughts about how ChatGPT writes code aside, let's go back and discuss the Turing test a bit further. There is one area where the Turing test is still used quite a bit, and that is in the field of artificial general intelligence. And in fact, when we're not trying to get a computer to do a specific thing, like come up with human-sounding responses, Getting a machine to pass the Turing test is a good indicator that it would be able to do many of the things a natural intelligence, a natural human intelligence that is, would be able to do. I also suspect that if we do come up with artificial general intelligence, as with many people, if it is not specialized, it'll do less well at the tasks it is designed to do than an AI that was designed to perform a specific task. Although most people know what the Turing test today is, even if they don't know the original formulation of it, they do not necessarily know that there were and still are objections to it. I'm going to go over some of them now. I'm also going to link the papers I got them from below, and of course one of them is Turing's own paper, where he responds to rejections of them. I found a more recent one to reference, however, and that's where these objections will come from. The first one is based on Gödel's incompleteness theorem. Gödel's incompleteness theorem proves that there are truths that can be expressed in any sufficiently powerful formal system that we humans can recognize as truths, but that cannot be proved within that system. This means that a computer would not be able to recognize them as truths, although it would not be a limitation for a human. Turing didn't give this response much thought, simply pointing out that humans are not perfect formal systems themselves, and there might be a limit to the truths they can recognize. Another objection comes from the problem of other minds. The only way to know if anything is thinking is to be that thing, so we cannot know if anything else really thinks. So basically, solipsism. Turing's reply to this was also pretty simple. If we adopt this position for a machine, we must also adopt it for other people, and few people would be willing to do that. Because honestly, if you think like I do, you have some really messed up thinking. And the final objection actually involves one of my favorite early computer scientists, Ada Lovelace. He simply called it Lady Lovelace's objection. In the 19th century, Ada Lovelace wrote that the analytical engine could not do anything they did not know how to order it to do. Turing's response was, well, that's not quite true, because in his day, even the simple computers they had then had advanced to the point that computers could in fact do things they were not ordered to do simply because the programmer made a mistake. He pointed out that although we did program computers using algorithms, they could often act in ways the programmers did not expect. This is something that is well known by today's computer scientists, software engineers, and programmers who know that bugs are a thing and just simply a fact of life. During the 1980s, papers on the Turing test appeared, and one of them by Hofstadter argued that even if a machine passes the Turing test, the machine still might not be intelligent. Of course, that's not really what Turing proposed anyway, because Turing was actually proposing a simulation of human intelligence, not actual human intelligence. In the 90s, people started to actually try a different idea, and rather than work on symbolic AI, they worked on connectionism. Now, it's clear that the 90s were also the decade that gave us the concept of neural nets, which most large language models use today. I'm not going to go into what a neural net is here. Although I could go deeper into the history of AI and point out where it has progressed over the last 20 years, which is an interesting topic to itself, because we are closer to actually passing the Turing test than we ever were before, I think it's important to know that passing the Turing test does mean we've probably achieved artificial intelligence. Now, if you've ever used "you couldn't pass the Turing test" as an insult, I have some bad news for you, because failing the Turing test means absolutely nothing. It just means you didn't pass the Turing test. The Turing test is not a test for a level of intelligence, but rather if a machine can behave the same way an intelligent entity would. As a side note to all of this, a journal that appeared in the Journal of Experimental and Theoretical Artificial Intelligence in December of 2014 actually decided to run the Turing test, but with a twist. None of the people on either side were actually a machine. They wanted to find out how good people were at identifying other humans, and the rates of misidentification were actually higher than they expected. And this has implications for the Turing tests because if we can't reliably identify if the person we're talking to is another human, as some of the data in the paper suggests, we also can't tell if we're talking to a machine. Now we come to the end of this video. If you haven't done all the things I asked you to at the beginning of this video, which include like, commenting, and subscribing, please do so now. If you have any idea for content you would like me to cover in the future, please use the comments section below and go out and write some code.